Here's the model of my skeletal muscle. And the whole entire muscle has connective tissue, which is called the epimysium. And within this is bundles, which are called fascicles. Sorry. And you see the fascicles are represented by my pens and pencils. And each fascicle actually has connective tissue, which I have also representing the aluminum foil. And inside the fascicle is muscle fibers, which within the muscle fiber is also connected with tissue, which is called the endomyosin. And then I do not have the inside layer of this, but the inside of the muscle fibers is contractile units called sarcomeres. And I have like a little stripe thing. And then like this is like, I'm gonna say this is my muscle fiber, and the stripes are the sarcomeres, which are joined end to end. And that's why I have the stripe like pattern on this piece of paper. Here's my sarcomere, and inside is actin and myosin. And there are two types of filaments. There's thin filaments called actin strands, and there's thick filaments called myostrands. And right here, the two little zigzags is my Z line, because the sarcomere is separated in sections by Z lines. And when sarcomeres contract, it brings together the Z lines, causing the thick and thin filaments to combine. And when the muscle cells are at rest, actin and myosins do not touch. So for example, whenever you have your arm out and you're in extending position, your actin and myosin are not combined, they're just at rest. But then when you flex your arm at your elbow, that's whenever your actin and myosin strands come together. But there's a little bit trouble with this, because your actin is tripped up by protein bodyguards called troponin and trypomyosin, sorry. And in order for them to get past this, you need ATP, so, which is energy, and calcium as well. And so, like I said earlier, when you're resting or extending your arm, you don't have any ATP, you're not using any energy. But then when you flex, you are using energy. And once you do that, actin and myosin bind. And the myosin head uses ATP to move from the rested position to the active position, as I explained. The myosin head is released and repeats this binding process and binding and pulling process until the action potential stops. What you see that I'm doing, what I'm doing is flexing and extending my arm, which is requiring ATP. And so once the action potential stops, which is me just stop pumping my arm, the calcium goes back into the sarcoplasmic reticulum. And this process requires ATP for the calcium pump to work. This happened, the trypsin and trypomyosin move back over the myosin binding site on the actin filament, and the muscle relaxes. And as you see, my muscle is relaxing because my arm is extended. Thank you.